Welcome. This is the last and final video I want to do just surrounding the idea of alkanes, alkenes, and alkynes. Now, sundries in English means extra, means miscellaneous, some additional information. So while it comes across as additional, it is important. And I want you to know that because at this point we are finished officially with alkanes, alkenes, and alkynes, and we've been on it for a little longer now. So it's important that you know this information. So this will be a very quick and crispy video, and there's not a lot you can memorize, not a lot you can also do about it, because this is one place where information is factual. So without further delay, let's go ahead and get that done. Well, we've talked about bonds, which is single, double, and triple. That means there's three basic things that we need to know about a bond, and first one on the list is bond length. Typically, the more bonds you have stacked on each other, it's usually shorter. So triple bond is usually shorter than a double bond, which is shorter than a single bond. So what I'm saying here is, this is your triple bond, and then your double bond, and then your single bond. So if a molecule, say for instance, okay, this, and then let's do the same, but this time let's add a double bond, and let's do the same this time, let's add a triple bond, okay? If I ask you which pair, if I ask you, say, the same area on all three molecules, or any area wherever these bonds appear, which fragment, okay, which is this, and this, is shorter or longer. So we know that this fragment, if we call this 1, let's call this fragment 2, we know this is fragment 3, then we know fragment 3 is the smallest, followed by fragment 2, followed by fragment 1. Okay, so bond length. Bond strength, it's the opposite of bond length, okay? Basically, think of it as this is just one tug-of-war rope, whereas you have two tug-of-rope wars, and you have three, or you can think of one piece of paper, two pieces of paper, and three pieces of paper. The more papers you stack, it's hard to rip them apart into two pieces, right? So bond strength is the opposite of bond length. So single bonds are weaker than double bonds, which are in turn weaker than triple bonds. So breaking a C single bond C is easier versus a C double bond C, which is exactly like having two papers, and then you have three papers on top. Breaking that is difficult, so bond strength is the opposite of bond length. Bond angle. Now, what do we mean by typically around a carbon atom is we always need an anchoring point in chemistry, okay? So remember, we know carbon can have 4 bonds, right? If all 4 bonds are single, okay, which is this case, this bond angle is 109 degrees, okay? We'll look at the geometry in the next slide, next screen. So if what I mean by single bond is if the carbon, doesn't matter what it is attached to, but the carbon itself, if it contains 4 single bonds, then the bond angle is 109. What do I mean by double bond? Well, you can have 2 single bond and 1 double bond, right? Because carbon can have 4 bonds, but it doesn't have to be all single all the time. We've already looked at it, right? For instance, when we wrote like this, right? If this is our compound, you see that this compound is attached to another carbon through a double bond, but then the carbon itself, this carbon itself contains this bond, and then this bond is attached to hydrogen, right? I'm only focusing just on this. So Carbon can have two single and double, and if that's the case, this bond angle is 120 degrees. Or carbon can have one single bond and a triple bond. In that case, this bond angle is 180 degrees. So we've learned about bond length, bond strength, and bond angle. And the final one is bond geometry. Again, similar to what I drew, if a carbon contains all single bonds around it, then the geometry is tetrahedral, which you see on screen. If a carbon contains two single bonds and a double bond around it, again, we're focusing on the carbon, okay? We're focusing only on the carbon, not on the double bond. Then the geometry of the carbon is triangular planar or trigonal planar, depending on which instructor is teaching the course and what they prefer. And if you have a carbon with one single and a triple bond, then the geometry around the carbon is linear. Okay, these are basic things that you want to know. So I want to wrap this video here because these are for information that's very important. You know, we've learned bond length, bond strength, bond angle, and bond geometry. There's really nothing to memorize here. I think if you watch it just more than once, you can get it. I will not provide this particular information, will not be made available to you. So you do have to remember this. But again, considering a long list of things, if I tell you occasionally this little piece of information is something you do have to memorize or remember, then that's exactly what you do. And that's all I have to say about sundries. And this is technically part of phase 1, and I'm going to begin phase 2 with a simple calculation thing because I want you to get started getting into the idea of seeing elements other than carbon and hydrogen, which is all you've seen pretty much most of the way. And then we'll get started. That'll lead us into the second big thing, which is nomenclature of functional groups. All right, so stay tuned.